In number 12, we are given the function f of x equals x squared plus x, and we're asked to find out some things about rates of change. In part A, we're asked to find the average rate of change over the interval from -1 to 2. Well, that's going to be the slope of the secant line on the, with endpoints at x equals -1 and x equals 2. So the formula for that is f of 2 minus f of -1 over 2 minus -1. Or more generally, if we're talking about the interval from a to b, it's going to be f of b minus f of a in the numerator, and then just b minus a in the denominator. So our a is -1, our b is 2. We need f of 2, which is 4 plus 2 or 6, and we need f of -1, which is 1 plus -1 or 0. In the denominator, we're going to have 2 minus -1, which is 3. So the average rate of change is 6 over 3, which is 2. In part B, we're asked to find the instantaneous rate of change in f at a single point. Remember that with the instantaneous rate of change, you're looking for the rate of change at a single point. And in that case, the rate of change is given by the derivative. So we want f prime of 2. Right? We want to evaluate the derivative of 2 because that's the x value we're talking about. All right, so the derivative is 2x. And if you substitute in 2, you get 4. That's the instantaneous rate of change. In number 13, we're looking at an object that is dropped from the top of an 800-foot tall building. And we're told that the height of the object, or really the distance above the ground, t seconds after being dropped, is given by s of t equals -16t squared plus 800, and that is in feet. In part A, we were asked to find the velocity function. Well, remember that the velocity function is the derivative of the position function. So in this case, that would be -32t. In part B, we're asked to find the velocity 2 seconds after the object is dropped. So we want the velocity at t equals 2. So v of 2 would be -32 times 2, which is -64. And the units would be in feet per second. In part C, we are asked, how long does it take for the object to hit the ground? So how many seconds does it take for the object to fall those 800 feet? So we've got two functions, the velocity and the position function. The velocity function isn't going to be that much use to us because we don't know what the velocity will be as the object strikes the ground. We do, however, know how high above the ground it'll be. It'll be 0 feet above the ground. So we're looking for where the position, given by -16 squared plus 800, is equal to 0. When is the height above the ground equal to 0? We solve this equation. All right, so let's write this as 800 equals 16t squared. We can divide each side by 16. And let's see, 800 divided by 16 is 50, I believe. So t will be the square root of 50. There's no need in going with the negative value of t. That's before we even drop the object. Square root of 50 seconds, that's a little bit more than 7, I believe. A little more than 7 seconds. And if you like, you can write that as 5 times the square root of 2. But I'm not going to insist that you do that. In part D, we want the velocity as the object strikes the ground. Well, again, we know that the velocity is given by -32t, and we know when the object strikes the ground. That's at t equals square root 50. Or 5 times square root of 2, whichever you like. So to find the velocity as the object strikes the ground, we'll find v of square root 50, which is -32 times the square root of 50, and that's going to be in feet per second. And I'm not sure what that is. I think it's more. It is approximately maybe 220, negative 220 feet per second. Maybe not, somewhere between negative 210 and negative 220, I think. If you have a calculator handy, you can figure that out. And then finally, in part E, we're asked for the average velocity over the time interval from t equals 1 and t equals 3. So the formula is pretty much the same as the formula for average rate of change, except instead of f of x, we're using s of t. So we want s of 3 minus s of 1 over 3 minus 1. Now you remember what s is. S is negative 16t squared plus 800. So let's see, when t is 3, this is going to be negative 16 times 9, that's negative 144, plus 800 is 656, I think. And at 1, it's going to be 800 minus 16, which is 784. And then we'll have 3 minus 1 here. Let's see, that's going to be negative 128 over 2, which is negative 64 feet per second.